project aimed to develop an implantable pacemaker charger to reduce battery replacement surgeries for people over 60, eliminating the high risks associated with it. The charger would be implanted alongside the pacemaker or during a battery replacement procedure due to the constraints set by our client, Gore. We decided to pursue piezoelectric over thermoelectric generation as it does not require induction and with the right piezo material can be placed inside the body.
Piezoelectric material generates electricity when deformed. The idea was to implant piezo peak wrap matrices in the pericardium sac within the heart. Based on the heartbeat, electricity would be created to charge the pacemaker. We built prototypes and put them to the test. We simulated heartbeats with servo motors. Unfortunately, the generated electricity proved insufficient when connected to a load. Increasing the number of piezos yielded no significant increase in the power output. Additionally, regulating the inherently inconsistent power from the heartbeat presented significant circuit design challenges.
While our initial concept did not meet our expectations, piezoelectric material proves to be a promising addition for other applications, but for this specific case, it does not generate enough power. This project highlights the complexity of designing implantable medical devices. The future of pacemakers might involve alternative energy harvesting methods with induction or external sources.